In 7E, we're going to sketch quadratics by using the quadratic formula. Okay, by using the quadratic formula. If we want to use the quadratic formula, we must have the general form of the quadratic. Okay, ax squared plus bx plus c. So I'll just add something. That's what I read yesterday. So quadratic formula. So we use quadratic formula to find x-intercept or intercepts. This is very similar to the x-intercept form. But the difference between we use the x-intercept form or using the quadratic form is depends on whether I can factorize the quadratic easily or not. If I can factorize it easily, I can find the intercept form and then I can find the x-intercept. But if I can't factorize it easily, it will be easy to calculate the x-intercept by using the quadratic formula. Then we can also find the x-intercept. So the difference between those two will be difficulty level of factorizing. Okay, if it's difficult to factorize, we'll use the quadratic formula. If it's easy to factorize, I'll factorize it. Okay, it's always like that. If it's easy to factorize, I'll factorize. If it's not easy to factorize, I'll use the quadratic formula to solve for the x-intercept, or I can put that into the turning point form. Okay, so that's what we have so far.
Some students, please excuse this interruption, could 11A and 11B.
All right. They just want 11A and 11B.
And to the following members from the senior badminton team, Amy Young, Rebecca Ingram, and Anusha Yogadra and Karina Park, please report to the gym now, please.
All right. So when we can use quadratic formula to find x-intercepts, okay, it will be exactly the same thing as x-intercept form. So, but we use quadratic formula to solve for the x-intercept. Okay, what's quadratic formula? Let's revise that again. X equals to minus b plus minus square root b squared minus 4ac over 2a. Okay, minus b plus minus square root b squared minus 4ac over 2a. That's the quadratic formula. Okay. When we know the x-intercept, then exercise 7c, what we learned yesterday, can be applied to sketch for the quadratic. Okay, let's do one example here. Y equals to 3x minus 6x plus 5. I can't find the x-intercept easily. So I can't factorize it easily. So we'll say when y equals to 0. 3x squared minus 6x plus 5 equals to 0. X will be minus b, which is plus 6. Okay, 6 plus minus square root b squared is 36 minus 4ac. Okay, let's have a look. What's 4ac? 15 times 4 minus 60 over 2a. And we find that there's no solution because that is less than 0. Okay, so in this case, a equals to 3, b equals to negative 6, and c equals to 5. Okay, we use the formula minus b plus minus square root b squared minus 4ac over 2a. And we find there's no solution because it's wrong. I can't have a negative number in square root. In this case, discriminant less than 0. So we have no solution for this equation. Okay, discriminant. What's discriminant? Discriminant is b squared minus 4ac. That equals to 36 minus 60. And that is less than 0. So there is no solution. Okay, it's a very unfriendly question in this exercise. Why? I try it first time and I find it's not working. I can't find any x-intercept. Okay, that's the problem. I can't find any x-intercept. So if I can't find any x-intercept, what we should do? Any thinking? Like I can't do this way now. Like this way is not working. What I can do to sketch for it? Seneca? Complete the square. Okay, complete the square. We need to further complete it. Okay, so the thing is, I want to factorize, and this one cannot be easily factorized. And I try quadratic formula, and I find, oh well, it's not working. And then I go back to the completing square. So what this case represents? Completing square is the easiest way. Not easiest, like it can work for all the equations. Okay, it can work for all the equations. Maybe it's the best way to sketch for quadratic, but it takes longer time. Okay, it takes longer time, but it always worked. It's always worked. But like quadratic formula and factorize, it not always work. Something cannot be factorized, and therefore I can't find x-intercept. Okay, and quadratic formula will not work as well. So this question tells us, in some case, we definitely need to complete square. We have no choice. So what we can do is 3x squared minus 2x plus 5. Okay, I leave the constant outside. If you want, you can put that inside. Doesn't matter. We have 3 bracket x squared minus 2x. I will plus 1 minus 1. So plus 1 squared minus 1 squared. Okay, before you do that, I'll just emphasize that last time. If you complete square, this bracket is still there. It not disappeared. You create a new bracket. It doesn't mean the original one get disappeared. So what we have inside is a x minus 1 squared and minus 1 and plus 5. Why there must be a bracket? Because when we expand it, that is not a minus 1, it's actually a minus 3. And that's a plus 2. So this is the turning point form. The turning point is 1, 2. The turning point is 1, 2. So 1, 2, which is here. What is the y-intercept? What is the y-intercept? 5? Okay, 5, 0, 5. So if that's 1, 2, that's 0, 5. I will have 2, 5 as well. So the shape of the graph will be that. Okay, the shape of the graph will be that. Symmetrical graph. Well, there's no x-intercept. You can see like there's no x-intercept after we sketch this shape. That's why the quadratic formula doesn't work. The quadratic formula can tell you whether there's x-intercept or not. But if there's no x-intercept, I can't use this method. Okay, I can't use this method. Okay, so the first exercise tells us sometimes I just can't use that way of sketching quadratic. Okay, so there's one way always worked, which is the turning point form. I always have I can always find turning point form for any quadratic. But in some cases, if it's easy to factorize, I can find the factorized form. Okay, if it's easy to use the quadratic formula, you can use the quadratic formula. But the requirement is there must be 2 x-intercept, and then you can do that. If there's no x-intercept at all, can't do that. Okay, next one. Next one. So we have this question here. Let's do try quadratic formula. When y equals to 0, minus 2x squared minus 4x plus 3 equals to 0. Well, too many negatives. I will go 2x squared plus 4x minus 3 equals to 0. I change all the sign. Well, it's not necessary, okay? Not necessary to do that. But I just don't want to see a is negative. So in this case, a equals to 2, b equals to 4, c equals to negative 3. That's the ABC value. So what x equals to? Well, let's check discriminant first this time. Well, maybe it doesn't work. So discriminant is 4 squared minus 4 times a times c. And that is a 16 plus 24. That's a 40. Okay, what x will be? Minus 4 plus minus square root 40 over 2a, which is 4. Okay, which is 4. So minus b plus minus square root b squared minus 4ac, which is the square root of discriminant, and over 2a. Okay, what that equals to? Okay, I'll separate that. That's a minus 4 over 4 plus minus. Okay, square root 40 is a 2 square root 10 over 4. Okay, I can do that. Minus 4 divided by 4 first, and plus minus square root 40 divided by 4. And I will have x equals to minus 1 plus minus root 10 over 2. What is this? How large is that number? Like approximately. Let's say we have minus 1 minus root 10 over 2. Approximately, what is it?
25.
You mean the plus one or the minus one?
Well, plus.
So let's think about minus 1 plus root 10 over 2 first. So how large is about root 10?
3.
Okay, about 2 to 3. Okay, it's about 2.4. Okay, it's about 2.6. 2.6. Wait, let me have a think. 3 to 4. 3 point something. Let's just say it's a 3. Okay, let's think about it's a 3 first. If it's a 3, so it's minus 1 plus 1.5, and that gives you 0.5. Okay, if that's a 4, it's a minus 1 plus a 2, and that's about 1. So this number will be in between 0.5 and 1. Okay, in between 0.5 and 1. Because root 10 is a number in between 3 and 4. It's more closer to 3. Okay, let's get closer to 3. Because 4 squared is 16. Okay, 16, so it's quite large. So let's label the first one. Okay, 0.5 to 1. So it's just somewhere here. Okay, that is negative 1 plus root 10 over 2, comma 0. How about the minus? So you have minus that. So if I change that to a minus, that's minus 3. That's minus 2.5. So it's in between minus 2.5 to minus 3. Okay, in between minus 2.5 to minus 3. So let's just say it's here. Minus 1 minus root 10 over 2, comma 0. Where is the middle? Now the question is, where is the middle? What's the middle between those two numbers? Okay, what you have is a plus that and a minus that. Where's the middle? Negative 1. Okay, you start from negative 1. You plus the same distance. You subtract the same distance. And the middle is still that negative 1. You from negative 1 go same length on each side. So negative 1 is the middle. So you will have that, okay, on this line. X equals to -1. X coordinates of the turning point equals to -1. So y value of the turning point will equals to, okay, I'll just put into the original function, -2, -1 squared minus 4, -1 plus 3. Okay, that is -2 plus 4 plus 3. That gives me 5. Okay, -1, 5. And we also know 0, 3 will be the y-intercept. Therefore, -2, 3 will be another point on this curve as well. 0, 3 is from the original graph, the plus 3. I have the y-intercept. Okay, now we have this many points. I can just complete the graph. Okay, that's the shape of the graph. Okay, you have this many points labeled on the curve. Well, not necessary to label this one. You must label the other 4. 2 x-intercept, the turning point, and the y-intercept.
Staff and students, please excuse this interruption. Include 11C and 11D. Please report to the gym now. 11C and 11D. Please report to the gym now. Thank you.
All right, we just have 2 exercises here. If you want, there's more on the textbook. I just show you 2 examples. One you can't do with this formula, one you can do with this formula. Okay, I just show you 2 cases. And, well, in this question, it's very similar to 7C. Okay, very similar to what we have learned yesterday. Where's the 2x intercept? We find that first. And where's the middle? We can find the middle quite easy by seeing this form. It's -1 plus a number, and -1 subtract a number. Then -1 must be the middle. Okay, -1 must be the middle. It's quite easy to find where is the middle. And then we find the x value of the turning point, y value of the turning point, and we label the y-intercept on that. Okay, we label the y-intercept on that. Okay, everyone, just give you, like, we learn all the techniques of sketching for quadratics. I just give you another general view on that because we learned something new here. Okay, so what I will do is I will start a line here. I'll start a line here. Okay, let's have a think. What we can do. We have y equals to ax squared plus bx plus c. Okay, the first thing we directly know from that is the y-intercept, which is 0, c. We have 2 things that we can do. Okay, we have 2 things we can do. Let's go for 1 and 2. Okay, the first thing I can do here is, I'll say, easy to factorize. Okay, if it's easy to factorize, we turn that into y equals to a x minus b x minus c form. Well, be aware of that. The a, b, c, the b and c here is not the same as b and c there. Okay, instead of make sure you're not confused, I will just use x1 and x2 in this case. From that form, I can know the x-intercept. It's x1, 0 and x2, 0. What I should do after that is find turning point. Okay, the x value of the turning point equals to those two x-intercept add up and divide by 2. Okay, so it equals to those two x-intercept, you add up, and that equals to 2. And then we sketch for it, and then we sketch for it. And in the second case, hard to factorize. Okay, if it's hard to factorize, I can go for two things. The first one is use x equals to minus b plus minus square root b squared minus 4ac over 2a, the quadratic formula. Okay, we use the quadratic formula to find x-intercept. And the next one is find turning point. It will be pretty much the same as the first method. Okay, it will be pretty much the same as the first method. But I will just draw this longer. But if it cannot, okay, I turn that down. If I go that method and figure out that discriminant is less than 0, I will find no x-intercept. I need to come to the bottom one as well. Okay, if you follow that path, then you need to go for that form, which is y equals to a x minus h squared plus k, which is the turning point form, gives us the turning point at h, k. And then after that, we find x-intercept or intercepts. Okay, that's a general view of what we will have to sketch for quadratic. Okay, that's a full map. What we should do. Okay, what we should do. If we're directly given that form or that form, we just directly use it. We just directly apply to it. Okay, I will print this page and upload that on Google Classroom as well, but just give you a view on what we have learned so far. Okay, so what we have learned so far. So I need to write this. This is by factorize, and this is by completing square. Okay, to that side, which is completing square. Okay, by completing square, we can achieve the turning point form. Okay, if you can't see it, you can come into the front and copy it. Okay, and then you can do some exercise for today. We have 2 more exercises to go.